Okay, students, today's topic is 8237 DMA controller. So, what is DMA? Direct Memory Access. Direct memory access transfers the block of data between memory and peripheral devices of the system without the participation of the processor. Whenever a peripheral device wants to access the memory directly, then DMA transfer will be used. The unit that controls the activity of DMA transfer is called a DMA controller. Whenever a processor has a DMA request from a DMA controller, it gives the control of the system bus to the DMA controller so that DMA controller can complete its task of data transfer using the system bus. How the DMA controller works. Whenever an input-output device wants to transfer the data to or from memory, it sends a DMA request to the DMA controller using DRQ pin. DMA controller accepts this DMA request and asks the processor to hold for few clock cycles by sending it the hold request using HLD pin. Upon getting a hold request by a DMA controller, CPU relinquishes the control of buses and sends the hold acknowledgement to the DMA controller. Now DMA controller gets the control of system buses to transfer the data between a peripheral device and memory directly without using processor. After receiving the hold acknowledgement, DMA controller acknowledges the input output device by using DMA acknowledge. That data transfer can be performed and DMA controller takes the charge of system buses to perform the data transfer. When the data transfer is completed, the DMA raises an interrupt to tell the processor that the task of transfer has been completed. So start with 8237 DMA controller. 8237 DMA controller is a multi-mode DMA controller. Multi-mode means it can perform operation in 4 modes. These modes will be discussed shortly. When a DMA transfer is done in a system, it will improve the system performance because the data transfer can be controlled by DMA controller and the processor can do a different task meanwhile. 8237 DMA controller has some features. These features are: it has 4 independent DMA channels, and it also has the facility to enable or disable the control of individual DMA request. It also has the facility of auto initialization of all channels. The data transfer can be auto initialized. It has memory to memory transfer. Normally a data transfer is done between a peripheral device and memory directly, but it also provides a facility to memory to memory transfer. Memory block initialization is there. data address increment or decrement. Software DMA request. DMA request is usually done by hardware devices, but it also provides the facility to request by software for DMA service. High performance. It provides data speed of 1.6 MB per second with clock speed of 5 megahertz. Now this is the block diagram of 8237 DMA controller. 8237 DMA controller has three control blocks. One is timing and control block, second command control block, and third priority encoder. Timing and control block provides timing and control signals as end of process, the transfer has been completed, reset to reset the data to reset the DMA controller, chip selection to select the chip of DMA controller, ready to synchronize with the slow devices as we have discussed in 8085 and 8086 microprocessor. Clock to work, it needs clock signal. AEN, address enable, address stop. These pins are used for address enabling, as we have discussed in demultiplexing of address and data buses. Then we use ALE. Then these two pins are same as ALE. Memory read, memory write, and input read, input output read, input output write. These control signals or timing signals are provided by the timing and control block. The second block, command control block, it decodes or interprets all the commands issued by the microprocessor to the DMA controller. This block specifies what a DMA controller will do. The operation of DMA controller will be defined by the command control block. Priority encoder will resolve the priority contention for each channel. The priority contention will be resolved in two methods: fixed priority and rotating priority. In fixed priority, each channel will have a fixed priority. Suppose DRQ will get the lowest priority, and DRQ 3rd channel will get 4th channel will have highest priority. So this is the fixed method. We fix the priority of channels. And rotating method, rotating, every time a channel will get serviced, it will get the priority, as the last service channel will get the lowest priority. This is the one example. The priority encoder block has pin DREQ, DMA request pin. Here the devices or software can request for DMA channel. After getting the DMA request, it will send a hold request HRQ to the processor. Processor will acknowledge of hold request by using HLDA, hold acknowledge. And then after getting the hold acknowledgement from the microprocessor, the DMA will acknowledge to the device, to the requesting device, by using DACK, DMA acknowledge. Along with these three control block, this DMA controller has 12 registers as temporary word count register, temporary address register, base word count register, current address register, current word count register, command register, mask register, request register, mode register, status register, temporary register. Along with these registers, it also has buffers. Buffers with data buses and buffers with address buses. So, as we have discussed, A237 has three basic blocks: timing control, program command control, and priority encoder block. It also has 12 registers as we discussed: base address, base word count, current address, current word, temporary word, temporary address register, status command, temporary register, mode register, mask register, request register. We will discuss the working of these registers shortly. I think we have done with the block diagram. The size of the registers are: for address register it has 16-bit size, word count register it has 16-bit size, temporary address and word count register also has 16 bits, status register 8-bit size, command temporary also has 8-bit size, mode register 6-bit, mask and request register 4-bit long. In the concluding remark, the DMA transfer, any device can access memory directly with the help of DMA transfer. And in this DMA transfer, a DMA controller will help. So, DMA controller will have some pins to get request and to make acknowledge. Some pins for specifying the operation, which kind of operation, input operation or memory operation. Some registers for addresses which tell where to from where to perform data transfer and to where perform data transfer, from source to destination address, word count, how many words will be transferred. So we will discuss shortly the working of register one by one. Thank you.